Here's a quick puzzle. Let us begin with this series that is perhaps familiar to most of you. A series of reciprocals of the natural numbers with the signs coming in alternate order. 1 by 1, minus 1 by 2, plus 1 by 3, and so on. I'm pretty sure most of you know that this series is convergent, and some of you may also know its sum. Its sum happens to be the natural logarithm of 2. Now, the reciprocals of odd numbers come with a plus sign, and the terms which are reciprocals of even integers come with a negative sign. Let us now just quickly reorder this series. Let me write down the reciprocals of the odd integers first. As you can see, I have left a gap between them, and of course I'm going to put in the rest of my terms of the series in those gaps. What I'm going to do next is write down halves of each of the numbers that I've written down already next to them. So 1 by 1 is followed by 1 by 2, of course with a minus sign. 1 by 3 is followed by a minus 1 by 6, and so on. Now this still leaves out those terms whose reciprocals were multiples of 4. And so we put them in next. Minus 1 by 4, minus 1 by 8, minus 1 by 12, and so on. Now you should be able to convince yourselves that this is exactly the same bunch of terms that was there in the original series. If you just look at the first couple of terms in each triplet, you get to see that there you're taking away half of a number from itself, and so the result is of course half of whatever number you started out with. And if you just carry out that calculation, the series now takes the form 1/2 minus 1/4 plus 1/6 and so on. It is obvious that I can take 1/2 common out from this, but the moment I do that, what I am left with is 1/2 times a series which is nothing but my original series S itself. So we end up with this amazing result that S is the same as half of S. And since S is not 0, neither is it infinite, it is perfectly legitimate to cancel out the S and land up with the result 2 equals 1. Now this of course is an amazing result, and it is of course also wrong. Can you figure out exactly what was wrong in the argument I have given above? Think about it. It's actually quite interesting.